Hi everybody, welcome to Shel lectures. So today we will be dealing with class 9 chemistry, the first level, class 9 science, the first lesson, matter in our surroundings. So what is matter first of all? Matter is nothing but anything that we see around us. Okay, anything that we see around us, all that we see around us which has a specific mass and it must occupy some space. So what are the two conditions to be said as matter? One is that it must have a specific mass and the other is that it must have a specific volume, that is it must occupy a specific space. For example, this chalk even. It has a specific mass, right? It has a mass and then also it's occupying some space in its surrounding. So it has some volume also. So anything which has both mass and volume is said to be matter. Anything which has both mass and volume is said to be matter. So matter is nothing but all the things that we see around us which possess mass and have volume. Earlier classification of matter, earlier people said that inside matter only these 5 components, one of these 5 components were present and this division was known as Panchatattva. Panchatattva, that is nothing but all the constant particles in matter are made up of only these 5 elements. That's what their theory was. So the earlier Indian philosophers, they said matter is composed of air, earth, water, sky and fire. Air, earth, water, sky and fire. So the earlier philosophers, the ancient Indian philosophers and the Greek philosophers, they said that matter is composed of 5 elements predominantly and they are air, earth, water, sky and fire. But the present day classification of matter is based on its physical properties and its chemical properties. So the present day, the modern day classification of matter is based on physical properties and chemical properties. Okay, so we are going to learn about the physical properties of matter in this lesson in detail. Okay, so this is what the introduction part. Matter is nothing but anything which possesses mass and volume. In the earlier classification of components which were present in matter, the earlier philosophers told that matter is composed of only of one of these 5 elements, that is air, water, earth, sky and fire. Yeah, that was known as Panchatattva. But nowadays matter is classified based on 2 aspects. One is their physical properties and the next thing is their chemical properties. So the first property of matter is that it is made up of particles. So from the early days itself, there has been a confusion whether matter is continuous as a block of wood. Is it matter or is it present in the form of particles? Is it particulate in nature? For example, sand. Okay, so there were 2 confusions. One is that matter is continuous, example block of wood, and the other is that matter is particulate, that is it's present in the form of particles, that is sand, example sand. So this kind of a confusion had been going on for years and years, and at last the philosophers and scientists came to a conclusion that matter is made up of particles, but we can't prove something without an experiment, right? So we'll perform one experiment now to know how people predicted that matter is made up of particles. Okay, so let's know that. So they took a beaker. They took a beaker filled with half amount of water and they added some salt here. What did they add? They added some salt here. So after some time you are immersing a glass rod and you are stirring it. So after some time what will happen? Can you figure out where the salt is? The salt which you added, it's here, the sugar is here. You can't figure out, right? So you can't figure out the salt and sugar which you added into the beaker. So what happens? It completely gets dissolved. Am I right? It just disappears into the solution. So that process is known as dissolution and that's an entirely different chapter. So what we are coming to know is, in this water only those sugar and salt particles are present even though you are not able to see them. So matter is made up of particles. Even this matter, it's made up of salt and sugar particles, which we may not be able to see, but there are particles inside matter. So from that they came to a conclusion that matter is made up of particles and the constituent particles in matter are particulate in nature. Okay, so this is how proved that. Okay, and then we have the size of these particles. So we said that matter is made up of particles. What about the size of the particles? So when I ask you broadly that what will be the size of the particles, you would tell me that very small. Yeah, it's absolutely right. It's to the smallest that you cannot even imagine. Okay, so for that also they have done an experiment. They have taken crystals of potassium permanganate. They have taken crystals of potassium permanganate. It's a violet colored crystal and they have taken just two crystals, two small crystals. They have taken two violet colored crystals of potassium permanganate and they have put it into a beaker filled with 100 ml of water. So a beaker is taken, it's filled with 100 ml of water and then two crystals of potassium permanganate are added. It's violet in color. So what is the color of the water which you predict in the next step? Of course it's violet. So when you do this, you are getting a violet colored solution. Right, this turns violet. Because we added two crystals. Now from this solution, I am taking just 10 ml in a test tube. So this is just 10 ml of this solution. Okay, this solution I am taking 10 ml and I am adding that into another beaker which contains 90 ml of water. Okay, so I have taken 10 ml from this solution and I have added into a beaker which contains 90 ml of water. So now I will be getting another solution from which I am just taking 10 ml in a test tube and I am putting it into 90 ml of water, and this process goes on like this for 8 times, 5 to 8 times. So this process is going on continuing. What is this process generally known as? We are just adding more water. Am I right? We are increasing the concentration of water and that process is known as dilution. Dilution is the process of adding excess amount of water. So we are just diluting it. We are going on diluting it and even then in the last beaker filled with solution, even this is violet in color. Even though you have done the dilution for 8 times, that is you have reduced the concentration of potassium permanganate by diluting the solution for more than 7 or 8 times, even then the final solution still retains the color, that is the violet color. How is this possible? I added just 2 crystals and I am just filtering it and 10 ml, I am putting it 10 ml, 10 ml, 10 ml, but still the color retains the same. From this what can we understand? 2 crystals of potassium permanganate are enough to color this much amount of solution. This much large volume of solution can be colored by just 2 crystals of potassium permanganate. So can you even find out how many particles will be there in each crystal of potassium permanganate? Yeah, it will be million in number. Okay, so there will be millions of constituent particles in one crystal of potassium permanganate. Only then we can get color, we can retain the color even after diluting it for 8 times. So from this they come to a conclusion that the particles of a matter are very small in size that cannot be even imagined. Also this experiment can be done with Dettol. This experiment can be done with Dettol. The same thing, you are taking a beaker, 100 ml beaker and you are adding Dettol, taking 10 ml, adding into 90 ml of water, preparing 100 ml solution, then taking 10 ml, adding to 90 ml of water. So if you are diluting it like this for more than 8 times, even then in the last solution you can sense the smell of Dettol. Okay, you can infer the smell of Dettol even though you dilute it for more than 8 times. What does this say? The particles are very small in nature. Okay, the particles are very small in nature as far as the particles of matter are concerned. Okay, so these are the observations that made us come to a conclusion that matter consists of particles which are very small in size. Now the third thing which we must know is that the space between the particles. So in a matter there will be a lot of of constant particles, as I told you earlier, even millions of constant particles in several matters. So the constant particles will develop a space between each other. Okay, the constant particles will develop a space between each other. What is this space meant for? For example, you are making coffee. What are you making? Coffee. What are the main ingredients for coffee? Coffee powder and sugar, right? What are the two main ingredients for coffee? Coffee powder and sugar. So coffee powder will have a lot of crystals and it will have a lot of constant particles, and sugar will have a lot of crystals and each crystal will have a lot of constant particles. Am I right? So only if there is a sufficient space between the constant particles of sugar, you can put these particles of coffee powder in between them. Right? So the space which is created by the constant particles of a matter is filled up by the particles of another matter. Okay, so particles of one matter make space and the space is occupied by particles of another matter. So space is very, very indispensable. Okay, so from this we can come to know that the constant particles are developing a space between themselves. That is the third point. So the first point which we saw was, what did we see? First point we saw that matter is made up of particles, and the second point we saw that matter is the particles of matter are very small, and the third part just now we saw that they develop space between themselves. And the next very, very important thing is D. The D thing is attract. The particles attract each other. So all the constant particles in a matter are held together by a force of attraction which stays between them. Okay, so all the constant particles are held together in a matter due to a force of attraction that exists between them. Okay, so this is actually D. The next one is going to be very important. This is just the force of attraction which exists between the constant particles, and the strength varies from one matter to another. Now the E part, it's very important, that is the constant particles in a matter move. They are never at rest, they are moving continuously. Okay, so the constant particles of a matter move continuously without even being at rest. And how are these particles moving? Because of the kinetic energy which make them move. Okay, kinetic energy is nothing but energy possessed by any object, any thing to move. Okay, so kinetic energy is indispensable for movement. So this kinetic energy makes the particles of matter move here and there. Okay, they will be developing kinetic energy and they will be moving here and there. So imagine your mom or dad who scolds you better, you can just take them as an example. They are scolding you, and after some time the intensity of their scolding gets bad and bad. What happens? It's inversely proportional to your degree of madness. Am I right? You will also be getting more and more mad. As your parents start scolding more, you will be getting mad more. Am I right? So that they both are directly proportional. So here also we have, on increasing the temperature of something, if I am increasing the temperature, the kinetic energy will be increasing a lot. What does that mean? The particles will be moving very fast here and there. So kinetic energy is directly proportional to temperature, which means if I am increasing the temperature, the kinetic energy will also increase, which also increases the movement of the particles in the matter. So when I am increasing the temperature, the kinetic energy increases, so the particles start moving here and there very faster. This is very, very important. So kinetic energy is directly proportional to temperature. And now here we have to learn the definition of another word, which is diffusion. Diffusion is nothing but intermixing of particles. For example, your mother is cooking a delicious biryani in the kitchen, and even though you are sitting in the hall, you can feel the aroma of your mother's food. Am I right? And immediately you go to your mother and ask, Mom, when will you provide that dish to me? Right, so even though you are sitting in the hall, your mother is cooking in the kitchen, even though you are getting the aroma of what your mother is cooking. This is only because the particles of the food are getting diffused into the particles of the air. Okay, they are just getting mixed with each other, and hence it reaches your nose and you are feeling the aroma. Right, so this is what is known as diffusion. The intermixing of particles or the intermixing of substances is known as diffusion. So that's it for today. In the next video, I will be meeting you with the other parts of this lesson. Still then, stay tuned to all of my videos. Subscribe to my channel if you have not done so far. Like and share this video to whomever you know. Thank you.